So in this video we're going to work out some voltages, currents and powers in resistors, and we're going to have a resistor in series and then two resistors in parallel with it. So on the left we've got R1. We've got a 20 volt supply, R1 on the left, and R2 and R3. R1 is 2.1 ohms, R2 is 5 ohms, and R2 is in parallel with R3, which is 6 ohms. So we're going to find all the voltage drops across the resistors. We're going to find all the currents through the resistors and the power in each resistor. Whenever you see resistors in parallel, first thing to do is work out what the equivalent resistor is for two of them. So we've got R2 and R3. We need to find the equivalent resistance of R2 in parallel with R3. And to do that, it's dead easy. You do product divided by the sum for any two resistors in parallel. So you multiply them together, then divide by what they are when they're added. So that's 5 times 6 divided by 5 plus 6. So that's 30 elevenths, which you can keep it like that, or you can use the decimal approximation. 30 divided by 11 is 2.72727272 forever, and you can round it appropriately. I'd use 2.7272 for now. So the circuit really looks like this. It looks like R1, which is 2.1 ohms, in series with another resistor, R2, in parallel with R3, which is worth 2.7272 ohms. And then the voltage source of 20 volts, like the battery. Step 2 is to find the total current in the circuit. And we can do that now because we know the total circuit resistance, or we can work out the total circuit resistance. So I is V over R for Ohm's law, so the total current is the total voltage divided by the total resistance. And the total resistance, RT, is just those two resistors added together. 4.82727 ohms. So the total current is 20 divided by 4.82727 for a bit of accuracy. That's equal to 4.1431 amps. So that's the total current in this circuit. And the total current runs through R1 and then it splits off into R2 and R3. Find all the voltage drops. So there's a voltage drop across R1 and there's another one across the parallel part. The voltage across R1 is the current times R1, V equals IR. So that's 4.1431 amps times R1, which is 2.1 ohms. And that's equal to 8.7 volts across R1. So the voltage across the parallel part must be 20 volts, take away the voltage across R1. So you do 20, take away that. It's 11.3 when you round it the same. So 11.299 volts is across the parallel part, because 11.3 and 8.7 add up to 20. So just draw them on, 8.7 volts there and 11.3 volts across there. So we found all the voltage drops, and I put a little X there just to show me what the voltage is at that point for working out currents later. The voltage at X is 11.3 volts. And the current in R2, I equals V over R, Ohm's law. So the current in R2 is the voltage across R2 divided by the resistance of R2. That's equal to 11.3 divided by 5. That's 2.26 amps because we used volts and ohms, so we're going to end up with amps. The current in R3 is the voltage across R3 divided by the resistance of R3, but it's in parallel with R2, so the voltage drop is the same. They both have 11.3 volts across them, R2 and R3. So it's 11.3 divided by 6 ohms, 1.883 recurring. So 1.88 will do for now really, or 1.883. But if you're going to use it later, be as accurate as you can. So the current through R3 is 1.88 amps roughly. So we've worked out all three currents and the voltage drops. So all we need to do now is the power in the resistors using I squared R for each one. If you want to check that the current in R2 and R3, if you add them together, they have to equal the current in R1, because it's like a river that splits off from R1 into two smaller rivers. Now for the power in R1 is I squared R, which is 4.143 squared times 2.1 ohms. That's 36.05 watts to 2 decimal places. So to get the power, you just square the current and multiply it by the resistance. So the power of R2 is the current through R2 squared times R2. Earlier we worked it out to be 2.26 amps squared times R2, which is 5 ohms. And that comes out as this. Which is 25.5, depends how you round it, 25.54 watts to 2 decimal places. And then finally the power, which is used up as heat in a resistor in resistor 3. That's 1.8833 squared times 6. 21.28 watts. So we've done everything that the question has asked, and hopefully this has been useful. Just remember that the main current flows through R1, then it splits off into two smaller ones, and we use Ohm's law and P equals I squared R for power. So thanks for watching and have a go yourselves.